Hey, it's Mr. Allred, and we've introduced functions, and the purpose of this unit is to learn how to graph quadratic functions. But before stepping into the quadratic functions, I want to review a few things, which are just graphing functions in general, because this is where we're starting. Review X and Y intercepts for when we talked about lines, and talk about lines a little bit again. And then eventually we'll get to graphing quadratics, which is not as hard as it may sound. So let's see here. The place I want to start is just graphing functions in general. So I have two functions here. The first one we've got is f of x equals 2x minus 1. And you may recall from the way I listed things, we could think about that as y equals 2x minus 1. And you may know a little bit about what this graph looks like just from seeing the equation, but imagine you don't. And let's say that if that's the case, that you need to figure out how to graph it. So let's just plot some points. So for x values, I've got a list of points here, but let's calculate them. So I'm going to plug them into 2x minus 1. So when I plug negative 2 in, I will get negative 5. And I can plot that point, negative 2, negative 5. I'll plug negative 1 in, I get negative 3. So I can plot that point, negative 1, negative 3. Plug 0 in, I get negative 1. So I can plot that point. If I plug 1 in, I get 1. So I can plot that point. And when I plug 2 in, I get 3. So even if you had no idea what 2x minus 1 is supposed to look like, you could come through and calculate a series of points until you felt very confident that you had a pattern and complete the connection of those points, and in this case to make a straight line the best you could. Okay. The second function I have here is an example. We're going to do the same thing. F of x, which we know we can call y if we like. F of x equals x squared minus 2. So if you prefer the y, that's fine. But the notation is kind of useful in getting familiar with it. So x squared minus 2, I'm going to throw in some x values, the same ones I actually used a moment ago. So if I plug in negative 2, that's going to give me a positive 2. So let's see here. Negative 2 gives me positive 2. Negative 1 gives me negative 1. 0 gives me negative 2. 1 gives me negative 1. And 2 gives me 2. So very quickly, if you plot this series of points, you realize you don't have a straight line. And in actuality, you may have no idea what you have, and these may not be the best points to kind of give you the shape. This is actually quadratic that we're going to explore a little bit more later on. But what we have here is if we try to connect these in a meaningful way, it makes a U shape, which we call a parabola if you're not familiar with it. And that's fine because that's what we're going to do later on. Oop, something disappeared. Still learning the ins and outs of the tablet. There we go. But if we have no idea what a function is going to look like and we're going to try and tackle it by hand, we can make a table, calculate some points, and plot them. That may be good for us. It may be bad depending on how much knowledge we have and which points we actually pick. Okay. So before we get into any real specific functions, let's review one thing really quick. X and Y intercepts. X-intercept is on the x-axis. So x-intercepts are on the x-axis. So that means they're on the axis that goes left or right. And if they're on the x-axis, they have a y value of 0, which means those points do not move off that x-axis, so they do not go up and down. So that's why they're all on that highlighted x-axis. And if you want to find one, you can let y or f of x be 0 and solve for x. And it's okay to have more than one x-intercept if you think about it, because if we were to draw something along there, I can draw whatever I want. I could have a function using that vertical line test even if I hit the x-axis more than once. Okay. Likewise, on the other side here, y-intercepts are on the y-axis and have an x value of 0. So here's the y-axis going up and down. So they have an x value of 0 because you can't move left or right if you're going to stay on that center axis. So if you want to find a y-intercept, you let x be 0 and solve for y. So in the same idea of something like I just drew, I can only have one x-intercept because I have to pass the vertical line test. So you can have many or no x-intercepts technically over here on the left, but you can only have one at most y-intercept over on the right because you still have to pass that vertical line test. So keep that in mind. Okay. One more thing I want to review before we move into quadratics, and that is the fact that we've graphed lines in the past. Remember y equals mx plus b, where m was the slope and b was the y-intercept. Well, we can turn that y equals mx plus b into f of x equals mx plus b, and now it's considered a function. It's considered a function even if you say y equals, if it works, but if you want to actually declare it to be a function, you can use the f of x. Y and f of x are used interchangeably, while f of x definitely carries more weight. So we have graphed linear equations or linear functions before, we just didn't call them functions. So I have an example here. F of x equals negative 3x plus 4. So just using the things that we've learned about graphing a line before, we think about that as y equals negative 3x plus 4. And the two things we get from there are that the slope m would be negative 3, which we can write as negative 3 over 1, and the y-intercept we said was 4, so we call that the point 0, 4. And look very closely here. Remember what I just said about y-intercepts. If I let x be 0, which is what I've done here, then if I let that part be 0, negative 3 times 0 is 0 plus 4, I get the 4 back. But let's graph this thing and then we will try and reconcile. So we have the point 0, 4, which is over here on my graph on the y-axis. Then I have a slope of negative 3, so that means from there I go down 3 over 1. Down 3 over 1. I don't have to do it over and over, but before we just, I missed it altogether. It's a little hard with this tablet, but let's see if I can do a little bit better. Well, we almost hit it. We tried. But that's how we graphed the line in the earlier sections when we looked at systems of equations. So every type of function, in this case when we're graphing lines, has its own attributes. And in the case of the linear function, y equals mx plus b, it was the slope that was very special and unique to us that helped us graph it. We're going to have different attributes for different functions. But while I'm here, we've already seen how we can get the y-intercept here. Let's also see if we can get the x-intercept. We can look at the graph, but let's get it from the function. So we said let y equal 0. So that would be our f of x. So 0 equals negative 3x plus 4. So I'll pull this over. So negative 3x plus 4 equals 0. When I solve that, I get x equals negative 4 thirds. No, excuse me. When I pull that 4 over, it's negative, so let's clean that up a little bit. So we get x equals 4 thirds. So that's 4 thirds for x and 0 for y. Now you saw what a difficult time I had trying to get this thing straight, but about 4 thirds is right in here. So if my graph had come across straight, it would have hit that point that we were talking about. So we're right in the correct vicinity. But every graph that we talk about as far as a function, we can look for x and y intercepts, and that will give us nice points to kind of help us get our graph in the right place. Okay. When we come back, we're going to go straight to quadratics.